very pleased to be joined today by Jim Bunsey, Director of Commercial Business Development for PERC, to discuss propane's role in maritime's path toward net zero emissions. Jim, to start us out, I'm certain that many people watching this already know about the Propane Council, but can you give us a by the numbers look at PERC today that gives a size and a scope to your membership, your reach, and your activities?
Yes, so the Propane Education Research Council, it's a great organization. So we're funded by the industry itself. So we get a fraction of a cent for every gallon of odorized propane used in the United States. We represent over 3,000 members, which are propane marketers who actually distribute and sell propane into the retail market. So we represent them. So by taking that fraction of a cent, propane education research. So we educate people about safe uses and practices of propane. We invest a lot of that money into research and development for a new product or cleaner product. And then, we reach out, with groups like this, find new industries and show where we can bring propane in, and it'll help us, clean up the environment, which is it's really exciting.
When you look specifically at maritime ports and logistics today, can you give us a scope of propane's penetration into those markets today?
So as we move into the market and you look at today's day and age, it's the electrification of everything. So we start to look at propane and how can propane help? We need energy. And so electrification and electricity is a way for us to transmit energy, but propane produces energy. So I go around the country and I talk to people about propane helping electrify the future. So as we go into maritime and we need more electric vehicles, we're going to have to charge them. So you look at propane. And propane right now, domestic propane, if we look at carbon intensity scores, we have a carbon intensity of about 79 across the United States. Depends how far we go. It could be a little bit more, it could be a little bit less. You look at the national average of the electric right now, it's 131. So right now with conventional propane, we can come in and we can help people electrify cleaner than the grid is today with on-site power generation with propane. You look at a lot of the power generation that's in the ports or what we're using for material handling, we're using a lot of diesel. So we can do diesel displacement by either helping charge electric vehicles, or we can actually have equipment, forklifts, port tractors, anything that we're doing for material handling, we can run on propane and we're going to be much cleaner than diesel. We just did a great project up in the port of Newark where we brought in port tractor, did a study, and man, it turned out even better than we thought. We had, we're cleaning up emissions and particulate matter by almost 99%. So diesel displacement right now with conventional propane that is available locally in every state, including Alaska and Hawaii, we have large amounts of storage and we have large amounts of availability. Right now in the United States, we're producing about 30 billion gallons of propane. Domestically, we used 10 billion gallons. We're exporting 20. So we're looking for diesel displacement. We already have the storage. We already have the availability. And so we can start switching this equipment over to propane right now and be ready for the future and help people clean up the environment.
So Jim, as you know, port facilities and ship owners are being pressed more than ever to cut their emissions dramatically. My simple question is, where does propane fit into this value chain? Ship owners, port facilities, they have a full list of alternative fuels, the fuel of the future that they're evaluating. Why should they be considering propane?
So one of the greatest things about propane is, like I said, it's very abundant and it's very affordable. So as we still look at alternative fuels, if there's not an ROI and affordability, it's hard to make that change. Because if it doesn't make economic sense, it's hard for people to make the right choice to help clean up the environment. So in the maritime industry, one of our biggest things when we have diesel or we have gasolines, it's an atmospheric fuel. They're actually open to the atmosphere. There's actually oxygen in their tanks and fuel can break down. On a propane system, we have moderate pressures. So we're looking at, if it's 60 degrees out, we have 100 PSI. If it's 100 degrees out, we have 200 PSI. Roughly low working pressures. And the reason why I bring that up, when we compare CNG, it can be up to 3,500 PSI. If we go to hydrogen, it's 5,000 PSI. So we have affordable infrastructure that's already built and ready to go, but it's a fuel that doesn't break down. It's great in the marine industry. We go over to Europe. I mean, even recreational boats are using LPG because it's affordable, but also, we don't have water absorption. You're around the ports, you're on the water. We have fuel breakdown. Ships can sit for a while, they're ready to go. We don't have to filter like we do the diesels. So we have abundant fuel that is very reliable and it's affordable to help them make that transition.
When you look at propane and its inclusion into that future fuel mix for maritime, what specific design modifications or variations opposed to what they're doing today should ship and boat owners and or ship and boat designers consider?
So we have some pluses and minuses, right? Because you guys are carrying weight. So of course we have pressure vessels to store our propane in. So there's going to be some more weight, but also if you're in the corrosive environments you're in, we actually have thicker walls. So you're not going to take up larger areas. It's the pressure vessel is just built differently than our diesel and fuel oils and gasoline tanks. So you actually add some, as they design the ships, become more rigid. I've been around a lot of the propane barges where they actually still run the barges off of propane, but then we're actually hauling 1.2 million gallons of propane at a time. But that pressure vessel being closed and being more resilient, that's environmentally friendly. If we have, it's contained and there's no spots for leakage. Okay. If propane would leak, we don't contaminate groundwater. We don't contaminate the ocean. It boils at minus 44 degrees. So if we would have a leak, it's very controllable, but it would go out and it doesn't pollute the environment. You look at any place where we're transferring product from one holding tank to another, we don't have spills and messes and have containment when we're set up. We don't need that. Kind of funny stories down in Port Everglades. We actually have a terminal down in Port Everglades, barge terminal that comes in. There was a leak in the system. So fire departments dispatched, they all set up their leaks and they called me in from the company where I worked. We go down to see what's going on. And so they set up all the containment. We're like, hey, I understand it was good. You took all this time. Did you contaminate in your foam? But actually we go to atmosphere. We don't pollute the atmosphere. We're not a greenhouse gas. And you didn't have to do all this because we wouldn't have polluted your groundwater and your runoff back into the ocean. So it's what we're used to. We're around it when we're doing it, because again, you're maritime, you have massive amounts of gallons. It's not like we have 50 gallons. We're talking about thousands of gallons because you're traveling far, and be prepared. But it's just as simple as you just refueling areas clean.
What about renewable propane? Where are we today and what steps need to be taken to make renewable propane a commercial reality?
So renewable propane has been a reality. About 5 years ago, we started talking about, the viability of being able to have renewable propane. So for the last 4 years, we've been shipping about 40 million gallons to California because that's where the tax credits are. So it's making sense. A lot of our renewable comes from renewable aviation fuels, where they're using food wastes, and start bringing it in. It's great. At the refinery, it has a carbon intensity of 11, as we were talking before. By the time we ship it to California, it's delivering today with a carbon intensity of 20.5. Now, what's important to your audience, if you buy propane powered equipment today, renewable propane doesn't change. So now you have a wide path to zero. So if it runs on conventional propane, it's going to be direct drop in. Some of the other renewable fuels, they're going to have to change fuel systems and pressures. But simple chemical formula of domestic propane, C3H8. 3 carbons, hydrogen rich, we got 8. So it's a very hydrogen rich fuel. That's why we burn so clean. But that being said, by the end of this year, we're going to have over 80 million gallons because refineries are coming on. They're seeing the value statement. We're seeing renewable propanes come from the Camelina plant or other plants where they're actually extracting the oil for a process for making propane direct. Right now, most of propane is a byproduct of other refining fuels. Now we're starting to look at processes where they're going to actually make propane. Reason why we're ahead of other products such as hydrogen and LNG and CNG is our infrastructure is already built. Like I said way back at the end, we have the refineries, we have the storage, we have the rail, we have the pipelines. We can move our renewable product across the country right now at affordable prices. So again, we have affordability, reliability, and economics to help us be successful in the renewable propanes. And then it's going to be, my sight on this is as we go from 40 million gallons to 80 million gallons, by the end of 2024, we're hoping to be 120 million gallons as processes start to come online, is we can blend it. So we can do a 10% blend or a 20% blend of that negative carbon intensity fuel if we're taking bad things such as methane and putting it with our conventional propane. We can be at or below zero depending upon the mixtures we have, and we don't have to be 100% renewable. So there's a lot of avenues open. So as I talk to my material handling and any internal combustion engines that are running on propane, you buy it today, you're cleaner than the electric grid, and you're going to be ready tomorrow, and there's your wide path to get you to zero.